Okay, so I've got several questions here that parallel the problems that I posted. Okay? How to graph 7/4 times x minus 3 squared? One way to say this is it's a f of x, a f of x minus h plus k for a equals what?
7/4.
7/4. H equals, kind of a no-brainer, 3. And k, we don't have anything out there, so k is 0. With f of x equal what function? What basic function?
X squared.
Toolkit function, whatever, huh?
X squared.
Yeah, it's x squared. So, you got your graph of x squared. 7/4 x squared is going to take every point 7/4 as far from the origin. And then you're going to shift that over here 3 units to the right. And that's all I'm saying. I've explained it a number of times, and y'all are actually appear to be fairly good at it. And the next one's another quadratic. So I'm not going to do that. Actually, what I intend to do, I'm going to do this one. Okay. So clearly A is 1/2, right? And h equals -1, it's x minus h, and k equals 3. Which means you take the 1 over x squared graph, which looks kind of like this. You move every point twice as close to the x-axis. So you get something that looks kind of like this. And since that's kind of close to the other one, let me use a different color. Okay? And then you shift it over -1 unit. And that takes the x-axis over to -1 and gives you a graph that, make it look like that one. It looks like this. I'm being a little sloppy here, but I'm just doing something that you hopefully know how to do. Then you lower 3 units. And your asymptote stays the same, but now it's down here somewhere. Okay? You should be familiar with that and be able to identify it when you see it. Okay, now we want to do this. Okay? Now, I'm throwing you a little bit of a curve here, because e to the x isn't one of our fundamental basic functions, right? Well, you got to know what e is. Okay, so okay, e's about 2.7. So what you're going to have is you're going to have the e to the x function. It looks just like the 2 to the x function, except the scale is different. So it's got the shape of the 2 to the x graph, but it's equal to 1 here. And when x equals 1, what we want to get is we want to get the e to the x graph. It has a shape, the same shape, but the scale is different because when x equals 1, this has to equal e. Which is about 2.7. Okay? So you got to come over here far enough. Well, first of all, you probably go up to about 2.7. You come over, and that's where x is 1. Okay? So that's your e to the x graph. Now what about e to the 0.04x? Well, x has to be a lot bigger to give you the same value. Like x has to be 25 in order that you get e to the 1 here, right? That makes sense? Okay? So, on that scale, before we get up to e, we've got to go all the way out here to, and it's really further than this, but let's just say 25 is here. Okay? Then your exponential function is going to look more like this. Didn't do a very good job there. I stayed flat too long, but get the idea? So it takes 25 years to get up to e. Then, I'm not going to spend too much time on this because okay, if I triple all these values, then my graph starts to look like this. So this is e to the 0.04x. This is 3e to the 0.04x. And then you subtract 2. So we've got -2 down here. And now we lower this graph 2 units. And it comes down to like about here. So this would be 3e to the 0.04x minus 2. If I put one like that on the test, it's not going to be a whole lot of points. So if you don't understand it at all, work on something else, and once you understand everything else, worry about that. The point of this is, this would be an interest function if x was time at 4% interest compounded continuously. So that's kind of good to know. Okay, that's all I want to say about that. Well, there are a couple of others. And we do have one more at the end, which is a polynomial, which we probably ought to look at. You get the idea. You should be able to graph from the basic functions and using common sense, okay? Mostly the basic functions. Once in a while, we'll lay some common sense on you. Okay, let's see, I've got f of x equals x minus 2 times x plus 3 squared times x minus 5 cubed over x squared minus 3x plus 5 times x plus 5 squared times 4x plus 5 cubed. Now it might look a little intimidating, but it's no harder to graph than any other. They're just a few more details. So how do we graph this? Well, and I'm not justifying and everything, we've done that already. Obviously have 0 at x equals 2, x equals negative 3, with multiplicity 2, x equals 5 with multiplicity 3. Meaning that this is going to be like a squared function, either opening upward or downward, with a vertex on the x-axis at x equals negative 3. It's going to be like a parabola with vertex at the 0. Okay? We don't know if it's going to open up or down. We'll figure that out. Okay? And vertical asymptotes at x equals negative 5, really you usually just talk about multiplicity of zeros, but in the polynomial that's a denominator, it does have a multiplicity 2. That's going to affect what happens. For x plus 5 is 0 when x is negative 5/4. So you can see that just set that equal to 0 and solve for x to get to 0. And the multiplicity is 3. And that's all. Why? Because x squared minus 3x plus 5 equals 0 has no solution. How do you determine that? You look at the discriminant, b squared minus 4ac. b squared is 9, 4ac is 20. 9 minus 20 is negative. You get a negative under the radical. You don't get any real solutions. So you're not going to get an asymptote out of that. Okay, so we take all that information, give ourselves plenty of x-axis to work with because it's quite a bit of information. We have zeros at 2, at negative 3, and 5. Put little x's there to indicate those are zeros. Now, I could write the multiplicity down here, but we'll just refer back up here to see the multiplicities. Okay? And then our asymptotes, our vertical asymptotes at x equals negative 5. So here's x equals negative 5. There's the line x equals negative 5. Going to have a vertical asymptote there. Okay? At x equals negative 5/4. Okay, well, negative 5/4 is a little less than negative 1. That's 2, so negative 1 would be here. I'm going to say x equals negative 5/4. And that's it. So that's not too bad. Now, all the x's are positive. So it looks like we've got an x multiplied by an x squared multiplied by an x cubed, which is like an x to the 6th, right? Down here, we got an x squared times an x squared times an x cubed, which is like x to the 7th. Did I add that up right? I think I did. That's unfortunate. Okay, anyhow. If x is a big number, then this just acts like 1 over x to the 7th. Okay, well, if x is a big positive number, all these are positive, so it's positive over here. Okay? If x is a big number, you got a bigger power of x in the denominator than you got in the numerator. So your end behavior is going to approach the axis. Going to approach 0. Because you'll be dividing bigger numbers into smaller numbers. On the negative side, it's negative. And it approaches 0. Now, all the way from negative infinity to negative 5, it's negative, it's approaching 0. So we can already tell that here the graph is going to do this sort of thing. Okay, approach the asymptote here, come down here. I'm writing it lightly to see what else we've got to deal with. Okay, now between negative 5 and 3, we can test this. And when we do, I'm pretty sure we're going to find, especially since what I just did kind of indicates it, that it's positive. Now you can pick a number between negative 5 and negative 3, like negative 4, plug it in and see that it comes out positive, okay? You don't have to do a lot of arithmetic. If x is negative 4, that's negative. Well, the square is always positive, okay? This is negative, and it's cubed, so it's still negative. So you got a negative and a negative, which is positive in the numerator. So you can just reason it out that way. We've done plenty of that, okay? Now between negative 3 and negative 5/4, what happens? Well, if you test it, I believe you're going to find that it's positive. I know that because if it's positive on this side of negative 3, since x plus 3 is squared, it's got to be positive on the other side. Because the only thing that could change sign as x goes across the x equals negative 3 would be this. But it doesn't change sign. Okay, it hits 0, but then it goes back positive. So, and we could kind of indicate here that this is then going to be like an upward opening parabola, at least very close to negative 3. Then, between negative 5/4 and 2, what happens? Gee, I don't know, let's see, yeah. It's going to change sign. So it's going to be negative here. And you're going to have a positive asymptote here. You're going to have a negative asymptote here. And then you get up to x equals 2. Well, you can plug in numbers or whatever. You're going to find out that it's positive here. And it's going to be positive here. So we can kind of draw the graph. It's going to do this. It's going to come down here. It's going to turn around. It's going to go back up as an asymptote. It's going to come up from down here. It's going to go through x equals 2. And it's going to come over here. Uh-oh. Never mind. It's going to come over here to x equals 5. Now x equals 5. Uh-oh, I'm in trouble. What'd y'all let that happen for? Something's wrong. Because at x equals, oh, this is 5, not 5/4. Okay, never mind. Okay. Of course, at 5, negative 5, it shouldn't change sign there. We got some things wrong here. Okay. Anyhow, at x equals 5, that's cubed. It's going to act like the cubing function. So it would have to do something like this. Now, none of that works, so I got to go back and figure out what I did wrong. Okay, I know it's negative here. Oh, wait a minute, yeah, it's degree 7, it's degree 6. Anyhow, it's negative here. At negative 5, at negative 5, it doesn't change sign. Why not? Now, I didn't actually test these numbers, but it stays negative, and you can test the numbers and see that. So it's going to do this. It's not going to do this. It's going to be still negative here. But then when it crosses a negative 5 force, it's going to go positive, so it's going to not do this. It's going to come down from here. Then it's going to be negative. It's going to go through here, and then it's going to come up through here like this. But then it's going to have to do this. Now that's fairly complicated, so I'll sketch it here. All my reasoning was right, but I had a wrong idea there. Okay, the graph is probably going to look something like this, and you understand how I reason out every step. You might not understand how I reasoned out this, but you understand how you can figure out whether it's positive or negative on every interval. Okay? And once you have that, you can draw the graph. The thing I want to emphasize here is the thing about multiplicity, and I screwed up the... Okay, this has to level off like a cubing function. So it's got to do this here. And I didn't draw that very well. Okay, you can look at your book. You got plenty of examples. It's not that hard to understand if you know the graphs of the basic functions. Okay?